Does inflammation accelerate cancer?
Yes, this is generally appreciated now, that cancer develops in cases where there is a chronic inflammatory reaction. Because here's what inflammation is. Inflammation is basically your immune system's first response against infection. I mean, we talk about antibodies. You know, so you get immunized so your body can make antibodies against polio or antibodies against various bacteria, diphtheria, tetanus, all of those things. Antibodies, specific antibodies, which target particular microbes, take weeks for your body to be able to make after the initial exposure. And then if you're vaccinated or if you get the disease, a second exposure can be done much quicker, but it's not immediate. So what happens when you get that, when you step on that rusty nail that might give you tetanus? Or you get a flea bite from a rat that's infected with bubonic plague, if you don't have any specific immunity. Well, you might die from it, but meanwhile, you might not, and in the meantime, your body is going to be throwing whatever it can at it by way of first responders. A non-specific immunological reaction where you get these activated white cells, macrophages they're called, they get activated and they start throwing out poison darts and fireballs and all of that on a molecular level to kill anything that might come in before it kills you. And in the process, it does a lot of damage. That's inflammation. Mm-hmm. Now, nowadays, with the typical glycine deficient diet, inflammation happens just as a response to tissue injury because the cells that cause it are too much on a hair trigger. They're overactive and they go into action, causing inflammation when they shouldn't. Well, tissue injury happens all the time. Tissue injury on a micro level happens in your circulatory system. Wherever there's a branch in an artery, so you naturally get turbulence. You naturally get micro injuries. And if they build up and if there's inflammation, chronically happening from micro injuries at these branch points in your circulatory system, like where your coronary arteries branch off, you end up with a heart attack. Like where your carotid arteries branch off, you end up with a stroke. Or where your renal arteries branch off, you end up with malignant hypertension. So this is the chronic inflammation in places like that causes cardiovascular disease. That is appreciated, but why that happens is generally not appreciated. And I understand now that that's mainly due to glycine deficiency.
So glycine deficiency, before you said our body has an abundant amount of it, and yet now you're saying because of the food we eat these days, we're not getting enough
well,
glycine.
there's plenty of glycine in the collagen of your body. It's the most abundant protein, the most abundant amino acid in your protein, but also as a single soluble amino acid. Just like methionine and a number of other amino acids, it has other metabolic roles besides being a building block for protein. And in the case of glycine, that metabolic role is to regulate inflammation and some other things. And so usually the free amino acid, not as part of a protein, but just the free soluble amino acid, is normally present in high concentrations in your blood and other body fluids. But typically it's not high enough. So we tend to experience chronic inflammation. So I feel so strongly about this. I actually set up Natural Food Science, and I have it available. I have a product called Sweetamine, actually.
Maybe we could get a close-up of that, or
I don't know. That's just one form of it. That's available on the website, naturalfoodscience.com or sweetamine.com. Or you can get just plain glycine and not as a tasty formulation necessarily. What I did is I put it in a formula so that it's tasty for people to just put it, one packet a day in a cup of coffee or tea, and you use it just like a sweetener, but it actually gives you 8 grams of glycine, which is about as much as you'd probably throw away by not eating the bones and connective tissues of the meat, fish, and poultry that you otherwise eat. So it's not so much what you don't eat, or it's not so much what you eat that causes inflammation, it's really what we don't eat. And in fact, I believe that one of the reasons why, no doubt you've heard cases like this or maybe experienced it. You go to the hospital because you have some complaint, some persistent pain, and they say, well, we're going to admit you to the hospital for tests. And so they wake you up in the middle of the night and they do blood tests and they do scans and they do all kinds of testing, and they say, after a few days or a week of that, they say, well, we can't find anything. And then miraculously, though, you seem to feel better, at least, and then they send you home. Well, what did they give you for dessert after your every meal at the hospital? If you know
Pudding.
what
I don't
or
know.
Jell-O usually.
Oh, Jell-O.
Yeah. Everybody knows the hospital meals have Jell-O for dessert. Jell-O is gelatin. Gelatin is collagen. I mean, for example, this 8 grams a day that you would get in Sweetamine or just by taking 8 grams a day of glycine is the equivalent of having about 16 servings a day of Jell-O.
Wow, that's
people generally are so glycine deficient, they have a couple of servings a day of Jell-O, they get a gram or 2 a day of glycine, they will actually feel better. Just like some scientific studies have actually shown that, yes, if you have grandma's chicken soup, you will speed the healing and shorten the course of colds and flu and heal better, and that's true. Mm-hmm. See, inflammation actually retards healing. When you sprain your ankle, and everybody knows, oh, you sprained your ankle, so now it's swollen and painful and immobilized and all of that, and everyone thinks it's normal, but why should that happen? Why should your body need to put ice on it in order to slow down its normal reaction to that so that you can heal? In other words, the normal reaction that the body has to blunt injury or burn injury or most injuries is not healthy. It's not helping healing, it retards healing.
Putting the ice on a sprained ankle? I mean, I thought
that's what you need, yeah.
Rest, something cold and something else that was...
Yeah, cold, well, the ice, yeah, that's one of the things.
Some of the...
The point is that your body is reacting in a way that is counterproductive when you have a typical injury because the typical diet is really glycine deficient. Now, there are a couple of other nutrients, too. Everyone talks about omega-3 fatty acids. Right? Everybody knows about omega-3 fatty acids. They also have an important role in the inflammatory process. Over 20 years ago in the classroom, in my biology classroom, they used to call me Professor Walnut because I used to talk about omega-3 fatty acids and walnuts as a perfect source of food, a perfect and complete food. And I realized it takes decades from any major scientific discovery before it actually gets out there into the public consciousness. So that's why I figured, well, I could make it available by setting up a website and a company. So, that would make it easy for people to get it and just to talk about it and also to write about it. I am also doing some research some animal research with a research foundation on rats, some on mice, hopefully with the National Institute on Aging. We're hoping to do a very, very large study in 3 different centers on lifespan in mice, and also some clinical trials with my son, who's actually a cardiology fellow at a major hospital in New York, to do studies on diabetics and heart patients to see how supplementation with Sweetamine, with glycine, will actually help them.
So this being a show that wants to extend life.
Yes, that's right. It's all about protection of life.
But yeah.
Yes, from conception to natural death, and I know we're usually focused on saving the lives before birth because that's where they are most vulnerable these days. But saving someone from getting sick and dying in their 50s and 60s from diabetes and heart disease and cancer, that's a very important activity in preserving life. And I think that's all valid medical research is about protecting and preserving human life. So,
well, let me ask you about diabetes. How would this additional glycine help a diabetes patient to retard the gradual effects of diabetes during their lifetime?
I'm glad you asked, because actually there are clinical trials of this. There's some animal studies and also a study done in Mexico City about 5 years ago on diabetic patients. And it not only helps to deal with the effects of diabetes, it actually helps to reverse diabetes. The reason is this. We all know now, everyone in medical research and many in the public understand that diabetes is often a consequence of having a little too much abdominal fat, right? Mm-hmm. And it may not show on camera right now, but I got a few extra pounds of it myself. And everyone knows
have
in
an
research
ample amount
that it's
myself.
the, yes, it's the abdominal fat, not just, fat in the buttocks or, subcutaneous fat elsewhere, but it seems to be that abdominal fat that leads to diabetes. And the question is why? Well, it's not so much the fat cells, but within that abdominal fat, there are a lot of inflammatory cells. And so one gets to a case of what's called metabolic inflammation, which shows up as insulin resistance, and then it shows up as type 2 diabetes, elevated blood sugar and diabetes. And it's probably because the beta cells, the cells in the pancreas that make the insulin, get attacked by these activated macrophages by a process of metabolic inflammation that is reversed actually when there is enough glycine. There was a very interesting study done on what's called metabolomics, where these days they do scientific studies that are called data-driven, where they take blood samples or tissue samples and they measure everything. They measure hundreds of different metabolites, hundreds of different proteins, hundreds of different genes. In this case, they measured hundreds of different metabolites, and they found that when they compared middle-aged people who had insulin resistance, pre-diabetes, to age-matched population of people who did not have insulin resistance, guess what the biggest difference was in their blood? The ones with insulin resistance had much less glycine in their blood.